Hello all. So in the last class we have seen the problems depend on the linear differential equation. If it is in the form of dy by dx plus py is equal to q, and where p and q are the functions of x, right? Now in this class we will see if it is in the form of dx by dy plus p into x is equal to q, and here p and q are the functions of y. Okay, both are the linear differential equation only, but here it is in the form of dy by dx and here it is in the form of dx by dy. Okay, and here p and q are the functions of y and here p and q are the functions of x. So how to solve this type of equation? Again the same procedure. First we have to find the integrating factor, that is e to the power of integration of p dy. In earlier case integrating factor is e to the power of integration of p dx, but here integrating factor is e to the power of integration of p dy. Okay, then find this integrating factor and write down the solution as x into integrating factor is equal to integration of q into integrating factor with respect to y plus c. Okay, if this equation is there, then the solution is y into integrating factor, but this is the linear differential equation in x, so here x into integrating factor, again q into integrating factor here with respect to y plus c. Okay, same procedure we have to use, only here we have here the integrating factor is e to the power of integration of p dy, and in this case integrating factor is e to the power of integration of p dx. Okay, so we will take one example, we will solve example depend on this. So here we have x plus 2y cube dy by dx. See here don't consider, here already it is in the form of dy by dx. So if you find dy by dx, then you will get it is y divided by, we want coefficient is 1, so x plus 2y cube, is it? Then if you separate the LCM, you will get y by x plus y divided by 2y cube. Okay, see in the, if it is dy by dx, then we want plus py is equal to q, and that q should be the function of x, right? So here we have it is the function of y. So here if you have dy by dx, then we want the function of x, but we have the function of y, so make it in the form of dx by dy, because here we get the function of y. Okay, for that make it in the form of dx by dy, don't consider dy by dx. So we have dy by dx is equal to y divided by x plus 2y cube. So make it dx by dy, because if you find dy by dx you will get the function of y, but if you are using first equation dy by dx plus py is equal to q, then we want p and q are the functions of x, but here we have y. Okay, so make dx by dy is equal to y by x, sorry, x plus 2y cube divided by y. Okay, sorry. So this is nothing but dx by dy is equal to, separate the LCM, you will get x by y plus 2y cube by y, that is 2y square. X by y plus 2y cube by y, that is 2y square. Okay, now bring this term on this side, because we want it is in the form of dx by dy plus p into x, right? So dx by dy minus 1 by y into x is equal to 2y square. Now see, this is equation in the form of dx by dy plus p into x is equal to q, where p and q are the functions of y. Okay, so here p is equal to minus 1 by y and q is equal to, you will get 2y square. Then find the integrating factor. So e to the power of integration of p dy. Okay, here with respect to y, this is equal to e to the power of integration of minus 1 by y dy. Integration of 1 by y is log y, so e to the power of minus log y. So again use the property, so we can write this is e to the power of log y raised to minus 1. So the answer is y raised to minus 1, that is 1 by y. Use the property, that is e to the power of minus log t. Okay, then this is the integrating factor. Therefore the solution is x into integrating factor is equal to integration of q into integrating factor with respect to y plus c. Okay, so x into integration this is the required solution of the given differential equation. Okay, integration is very easy here. Only you have to know first whether we can write it is in the form of dy by dx or we can write it is in the form of dx by dy. If any example is given, then first check whether it is in the form of dy by dx or it is in the form of dx by dy. See, in the question it is given dy by dx. It doesn't mean that directly you will make it in the form of dy by dx plus py is equal to q. No, because we want p and q are the functions of x. But if you make dy by dx, you will get q is the function of y here. So when p and q are the functions of y, if it is in the form of dx by dy, so make dx by dy. Okay, so depend on these functions of p and q. So we have our next example is solve e to the power of pi dx plus 1 plus x into e to the power of pi dy is equal to 0. E to the power of pi dx plus 1 plus x into e to the power of pi dy is equal to 0. If you check again, you will get the functions of pi. Then for that make it in the form of dx by dy. So here we have already e to the power of pi dx. So we will get e to the power of pi divided by dy here. So dx by dy plus we remains with 1 plus x into e to the power of pi is equal to 0. Okay. Divide this equation by dy. Then you will get e to the power of pi dx by dy plus 1 plus x into e to the power of pi. Here we have dy, so dy get cancel. So we remains with 1 plus x into e to the power of 1. Okay. So solve this, make the coefficient of dx by dy is equal to 1. So divide this equation by e to the power of y. We will get dx by dy plus, I will write this term first because we want it in the form of p into x, right? So x into e to the power of y divided by e to the power of y. Transfer this one on this side. We will get minus 1 divided by e to the power of y. Okay. See, because we want dx by dy plus p into x, right? So for that, take this term and transfer the constant term on that side. So we will get dx by dy plus, here e to the power of y, e to the power of y get cancelled. So we remains with x. This is equal to minus. Take this e to the power of y in the numerator. Then it becomes e to the power of minus 1. Okay. Now it is in the proper form. Dx by dy plus p into x. So here the value of p is 1 because coefficient of x is 1. And q, value of q is minus e to the power of minus 1. So first find integrating factor. So integrating factor is e to the power of integration of p dy. So this is equal to e to the power of integration of 1 dy. So integration of 1 with respect to dy is 1. So integrating factor is 5. Therefore the solution is x into integrating factor. This is equal to integration of q into integrating factor with respect to y plus c. Substitute the value. So x into integrating factor is e to the power of y. Integration of value of q is minus e to the power of minus y into integrating factor is e to the power of y with respect to y plus c. Okay. Try to solve this. We have e to the power of minus y into e to the power of plus y. X into e to the power of y. Take minus sign outside. Okay. Here we have e to the power of minus y into e to the power of plus y. We will get e to the power of minus y plus y. Minus y plus y is 0. So we will get e to the power of 0. E to the power of 0. But e to the power of 0 is nothing but 1. Because anything to the power of 0 value is always 1. So 1 dy. Integrate this. Integration of 1 dy is 1 plus x into e to the power of 5 minus 5. Or take, if you want, take this term on this side, you will get plus. This is plus y is equal to c, which is the required solution of the given differential equation. Okay, so x into e to the power of y plus y is equal to c. Next we have solve solve 2x minus 10 y cube dy by by dx plus y is equal to 0. Solve 2x minus 10 pi cube dy by dx plus y is equal to 0. See, whatever I solved in the first example, you will get the same case here. If you use dy by dx, you will get a function of y only. Okay. So directly we can write down this in the form of dx by dy. So for that, first make it the coefficient of this is 1. So you will get dy by dx is equal to, transfer this plus 1 on this side, it is minus 1 divided by 2x minus 10y. See, we have y constant. Okay. So for that, make it in the form of dx by dy. So dx by dy is equal to 2x minus 10y cube divided by minus y. So you will get separate the terms. So dx by dy is equal to, first term you will get minus 2x divided by minus 5. Okay, sorry, minus 2x divided by y, because we have minus sign. Next, minus into minus, this becomes plus 10y square, because 1 y get cancelled. Okay, so minus 2x divided by y plus 10y square. Now bring this term on this side. Next term. So dx by dy plus 2 by y, this minus becomes plus 2 by y into x is equal to 10y square. Now it is in the form of dx by dy plus px is equal to q. Okay. So here we have p is equal to 2 by y and q is equal to 10y square. So find the integrating factor. So integration of p dy. So this is nothing but e to the power of integration of 2 by y dy. 2 is constant and integration of 1 by y is log y. So e to the power of 2 log y. E to the power of 2 log y. Again use the property. E to the power of log t. So first make it in the standard form. So we get integrating factor is e to the power of log y square. Log y square. Okay. Then e to the power of log y square nothing but y square. So integrating factor is y square. So here you will get the solution is x into integrating factor is equal to integration of q into integrating factor dy plus c. So x into what is integrating factor, we have y square. This is equal to integration of what is the value of q, we have 10y square into integrating factor that is y square dy plus c. So 10 is constant, take it outside. Y square into y square you will get y raised to 4 dy plus c. Integrate this. Integration of y raised to 4 is y raised to 5 divided by 5. Okay, y raised to 4 plus 1 divided by 4 plus 1, that is 5. So 5 is the 5, 5 is the 10. We will get 2 y raised to 5 plus c. So x into y square is equal to 2 y raised to 5 plus c. So this is the required solution of this given differential equation. Okay. So there is one more problem. Already I have solved the same type of problem in case of dy by dx. Here we will use the dy by dx by dy. Okay. So I will give that for the PDF. Please go through that problem. So this all about the linear differential equation. Either it is in the form of dy by dx or it is in the form of dx by dy. Okay. So this is about linear differential equation. Please solve these problems. If you are getting any doubts, you can ask me. In the next class, we will see how to find the solution if non-linear differential equation is given. That is Bernoulli's equation is given. Okay. So we will see that in the next class.